LDP neighborship. In this video, I'm going to talk about LDP neighborship as a main topic, and also I want to talk about some MPLS architecture terms such as LSP, FEC, and maybe other terms. Let's get started with the LSP. LSP is label switched pass. Label switch pass or LSP. This is the first term I want to talk about it in this video. Look at this picture. You can see a provider. This is a provider with 4 LSR. 1 LSR, 2, 3, and 4. And you know that the LSRs at the edge, we call them edge LSR. Okay? Edge LSR. We have 2 edge LSR in this scenario and also 2 core LSR. The traffic is received from 1 edge LSR, forwarded to the MPLS domain with a label or maybe 2 label or 3 label, and after that the packet forward to the other router, other LSRs, and finally the packet reaches to the edge LSR, egress LSR, and then the packet goes out after removing the labels. But what is the LSP? Label switch pass. A label switch pass or LSP is a sequence of LSRs. That switch a labeled packet through an MPLS network or part of an MPLS network. This means that this pass include ingress LSR, 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 and egress LSR is a labeled switch pass. Again, a label switch pass or LSP is a sequence of LSRs that switch a labeled packet through an MPLS network or part of an MPLS network. Also, don't forget that a LSP is a unidirectional pass. You can see that our LSP in this picture starts from ingress LSR, the left edge LSR, to the right LSR, the egress LSR. Okay? Because of that, if a packet should send from, for example, router 1 to router 2, this is router 2, C1 to C2, the packet first should go inside of the first LSP. This is the label switch pass, such as a tunnel, okay? And after that, when it reaches to the egress LSR, means the egress router of this LSP should go out and reach to the R2. And then, when the response packet from R2 should send to R1, okay, this packet first enters to this router, this edge LSR, and then the packet tunnels to the other edge LSR and finally go out to the tunnel, from the tunnel, and sends to router 1. This means that in the for the first packet we use this tunnel, okay, the tunnel is showed here, and for the response packet we use another tunnel, this tunnel. Look at here, this is so important to good understanding. Look at here, this is the LSP, second LSP. In the second LSP, the right router is ingress LSR and the left router is the egress LSR. Okay, because of that, every LSP is unidirectional. We have 2 LSP in this scenario. Okay, this is the first terminology, the first concept that you should know about MPLS LSP. Let's look at our scenario. I'm going to our scenario. This is a scenario that we have R1, R2, R3, R4, and R5, and we should enable MPLS on this scenario again. And after that, we can talk about many interesting topics about LDP And for example, I want to talk about how in LDP neighborship does occur, what is the process, and what is the detail. For the scenario, you can use R1 as a customer edge, R2 as provider edge, and other routers. But for this scenario, it's not necessary to mention about the provider. But in MPLS VPN network, we use many of these terms. Okay, let's first start with this scenario. Again, such as previous scenarios, we should enable the routers with IP address and routing protocol, and after that we can start the configuration and learning of the LDP as a label distribution protocol. From my notepad file that I will give you, I copy the configuration. First R1, I'm copying the configuration, and then R2. This is the configuration of R2. I'm copying the configuration to R2. Again, R3. You can see that this configuration also include IP addressing, enabling interfaces, and also enabling routing protocol, that is OSPF. And we should enable MPLS after this configuration. And finally, in the router R3 and then router R4, okay, EN here, and copy this configuration and paste on the R4, finally R5. Okay, the next step is to enabling MPLS. Which method we can use in this scenario? One of two methods that you know, that you learned in the previous scenarios. For example, we can use the interface method, interface ETH00, and I want to use MPLS IP. Again, for R2, conft interface ETH00, and I want to use MPLS IP. Look at here, you can see that neighborship, LDP neighborship does occur because you enable MPLS IP in both sides of a link. But what does it happen in this link? What is the details? This is important to know the details of the process. Okay, details of the process. I want to show you and I want to talk to you for you about the LDP neighborship. Okay, LDP neighborship, and also about some important aspects in the LDP. The first topics I talked about that is the LSP. You are now understanding the LSP. Okay, LSP or label switch pass. Label switched pass. Okay, the second thing that I want to talk about this is the name that we call it, is the concept that we call it FEC. FEC is the abbreviation of forwarding equivalence, equivalence class. Okay, forwarding equivalence class, a forwarding equivalence class or FEC is a group or flow of packets that are forwarded along the same path and are treated the same with regard to the forwarding treatment. Okay, I explain it more. Look at here. For example, we have a scenario R1, R2, R3, R4, and R5. And here we have a web server with IP2 as IP address. Okay. And here we have a PC1 with IP1 as IP address. And we enabled MPLS between R1 and R2. And here again, R1, R2 and R3, R3 and R4, and also R4 and R5. Okay, this is our scenario.